is a NEET 2019 question which has a combination of concepts of friction as well as circular motion, right? Let's have a look at the problem. A block of mass 10 kg is in contact against the inner wall of a hollow cylinder drum of radius 1 meter. Let us try to visualize what he's trying to say, right? There is a cylinder. Hollow cylinder is like this. The inner wall of this hollow cylinder, there is a block who has a mass m, 10 kilogram. This cylinder is having certain radius, obviously. There is some radius. Coefficient of friction between these two is given for you, mu as 0.1. The minimum angular velocity needed for the cylinder. Now we shall rotate the cylinder like this, so that to keep the block stationary when the cylinder is vertical and rotating about its axis. So even when this cylinder is rotating, this block shall remain stationary. That's the question that he is saying, right? Okay. So what are the forces acting on the block? Let us try to understand, right? The first thing is, uh, being the body is in circular motion with an angular velocity omega, there is a centripetal force acting towards the center called mr omega square on this body, on this block. Centripetal force always acts towards the center, right? So for the block now, to understand, cylinder becomes a frame of reference. What kind of a frame of reference it is? Non-inertial frame of reference, because it's having some force as well as acceleration. So to apply laws of motion on this block, we shall eliminate that non-inertial frame concept by applying a pseudo force. That could be also called something like centrifugal force. Sometimes you can call that way also. This is pseudo. This is not actually there. We have imagined it on the block because the block is in a frame of reference who is having that force. So it is a non-inertial frame. To apply Newton laws of motion, we shall apply pseudo force concept. So what is this mr omega square? This is applied by the block that we have taken on the wall of the cylinder. That's an action, right? The wall thus applies a reaction which is called normal reaction. Same magnitude but opposite direction. Let us consider the other forces acting on the system. Yeah. The weight of the block obviously always acts in downward direction, and as it is trying to slip down, frictional force tries to oppose that slipping. Thus the frictional force is acting upward perpendicular to normal reaction, right? So what we can say for the block, not to slip even when the cylinder is rotating, force acting upward directional frictional force shall be equal to force acting in downward direction. That's the weight of that block. Frictional force is mu into normal reaction, that is mg. Normal reaction is nothing but mr omega square, as I have explained earlier. So mass can be cancelled, so it's independent of mass. So omega square equal to g by mu r, omega equal to square root of g by mu r. This is what you are asked to find out. Let us just substitute that, then it becomes easy for you. Thus, the angular velocity for the block not to slip is root of g, value is given as 10, mu value is given as coefficient of friction as 0.1, radius is given as 1 meter. That is root of 10. 0.1 is 1 by 10. When it goes to numerator, it becomes again 10. Root 100 is 10. That is 10. Angular velocity is d theta by dt, radian per second. So the answer for the problem is 10 radian per second. That's how we have to solve the problem. And the most important part of the problem is considering this centrifugal force or pseudo force to eliminate the impact of non-inertial frame on the block. And we can consider in any of the way and we will get to the same answer. That's how we have to solve the problem. Thank you for watching.